So let's remember before going to 3.2, let's remember what we had in 3.1. Do you remember what we had in 3.1? We have the derivative of any constant with respect to x, with respect to another variable. It is what? It is 0. The derivative of x with respect to itself, when you differentiate it with itself, it is 1. Do you remember that? Also, the derivative of x to the power n, the power rule, it is n x to the power n minus 1. This is a very important rule. We had also the derivative of the exponential function. It is itself. It is very nice, cute function. What else? We have learned also that the derivative of the constant multiplied by a function, if you have a constant multiplied by the function, what will be the derivative? The derivative will be that constant multiplied by the derivative of that function. Also, we have studied the sum and the difference rules. If you have f plus g, then its derivative will be f prime plus g prime. Notice that I'm mixing between the Leibniz notation and the Newton notation. So it's okay. If it is minus here, you can also use the minus here. Okay. We have also, I advise you to add, for example, this one. It is a special case from this, but it is important because we will use it several times. The derivative of the square root of x. Also, when you have the derivative of a multiplied by x, constant multiplied by x, it is a. So what I advise you to do, ya shabab, is to have your own table. So what is your own table? You should have a table like this. Here, write the function, let's say f, and here write f prime. And start update your table every day. Every day you learn new derivatives, add them to that table, and of course this will help you to find the derivatives in a quick and correct way. What we are going to learn today is the product and the quotient rule. You can see here, ya shabab, you can distribute the derivative. You can distribute the derivative over the sum and the difference, but we cannot do that over the product and the quotient. So when you have f times g, the derivative of f times g, it is not f prime times g prime. Similarly, if you have f over g, if you differentiate, it will not be the derivative of the numerator over the derivative of the denominator. This is wrong. Okay, so they are not equals. What is true, طبعا? What is true that it will be like this. The derivative of f times g, it will be the derivative, the f times the g derivative plus g times f derivative. This is what is true. So it will be the derivative of the first time, the first time the derivative of the second, and the second time the derivative of the first. And of course, for the quotient, what is the right one? The right one will be, if you have f over g, the derivative of this will be what? F times g prime minus, sorry, g. Here it will be g, the denominator, g f prime minus f g prime over g squared. We will have it next slide with the proof, inshallah, for the both. I think for the one of them is enough to prove it. So this is what we have, only the product rule and the quotient rule. Here they are. This is the product rule and this is the quotient rule. Let's start with them one by one. So the product rule, how to prove it? The proof is easy. There is a proof in your book. طبعا you need to use the definition. You remember that when you have f prime of x, what is it? It is limit when h goes to 0 for f of x plus h minus f of x over h. Most of the questions in the first online assessment, it was about this definition. With the tricks, of course. There were some tricks about this. Now, I told you that there is another kind of definition that we can use, the alternative definition, like this. So we can use it here. Our function here, it is not f, it is fg. F times g. Here it is. So what I'm going to use to prove, I will use this definition. Here it is. So what I did, the derivative of f times g, it is f times g at t minus f of f times g at x. Now what I'm going to do, shabab, I'm going to add 0. Is there a problem if I add 0? So I will not change. But I will not add any 0. I will add a hero 0 that helped me to solve. So I'm going to add this 0. Look at this 0. This is the main trick in the question. Why I add this? Because I need to prove. This is my target. Now I add what? F at t g of x plus f of t times g of x. Now I will take here f of t as a common factor. Here I will take g of x as a common factor in the last two terms. Now if you take f at t here as a common factor and distribute this, separate the two fractions, look what you will have. F of t as a common factor, you will have g of t minus g of x. Here you will have g of x times f of t. Now if I distribute the limit, what will be this? When t goes to x, so it will be f of x. Now when I have the limit of this, what is the limit of this? What is this?
The derivative.
Derivative of x, of g. The derivative of g, and this is g of x, and when you distribute the limit, it will be g of x, and when you distribute the limit here, it will be the derivative of f. And we have proved the theorem. We have proved that the derivative of the product is the first one times the derivative of the second. Here it is. In words, the product rule says that the derivative of a product of two functions is the first function times the derivative of the second plus the second times the derivative of the first. And not only that, you can apply it for when you have a product of many functions, you can apply it, repeat it this way. In a shorter notation, if you put this equals to u and this equals to v, then the derivative of uv will be u dv dx plus v du dx. This will help you to prepare for Math 101 with this notation, with Leibniz notation. Let's have an example. X e to the power x. Find f prime of x. What is the derivative, the first derivative of x e to the power x? Now, it is very easy. Do you agree with me? This is x e to the power x. The derivative of this function will be just, what is the derivative of x? 1. What is the derivative of this one? Itself. So the derivative of e to the power x. Am I right?
No.
This is wrong. Because you didn't use the product rule. You did the mistake that I told you at the beginning. You just take the first derivative of the first times the derivative of the second. And this is not true. What you should do, you should consider it as a product of two functions. So you should apply the product rule. So now here, by using the product rule, what is the derivative of this function? Will be the first one times the derivative of the second plus the second multiplied by the derivative of the first. And what is the derivative of e to the power x? It is itself.
E to the power x.
And the derivative of x, it is 1. If you simplify, this will be e to the power x. And you can take it e to the power x as a common factor. Take e to the power x as a common factor. This is what you are going to have. Take it as a common factor. Here it is, x plus 1. So now you can skip this step. No need to write this step if you are aware about it. But it will remind you to use the product rule. And you can go directly from here to here. Now this is the first derivative. Part A is done. In part B, he wants you to find the nth derivative. Wow. So where n here is of course positive integer. So you need to know what is the second derivative, what is the third, what is the fourth, and what is the nth, such that you can find it at 1,000, at 100,000, whatever. So now what you need to do to go to the higher derivatives. So find the second derivative. The second derivative, what will be, Shabab? The second derivative will be the derivative of the first derivative. So you will differentiate this again to have the second derivative. And what you will do, you will apply the product rule again. So it will be the first one times the derivative of the second plus the second times the first. And according to that, what will it be? It will be, what is the derivative of this itself? The derivative of x plus 1. What is the derivative of x plus 1, Shabab? The derivative of x plus 1, it will be the derivative of x plus the derivative of 1. The derivative of x is 1 plus the derivative of 1, because 1 is constant, is 0. It will be 1. So here it is. We apply the sum rule over there. So you need to practice, Shabab, by finding so many derivatives until you understand. Now again, take e to the power x as a common factor. You will have x plus 2. What do you notice? Do you notice what happened when we had the zeroth derivative? By the way, Shabab, when you have f(n) of x, this when n is 0, you have the original function. It is the original function. So in fact, the original function, it is this, and this is the first derivative, the second derivative. And what you can notice, ya Shabab, what happened?
We add 1.
We adding 1. Excellent. So the third one will be x plus 3. You can check. If you are not sure, you can find the third derivative, the fourth. It is not difficult. It is easy. Now, can you conclude what will be the nth derivative? It will be x plus n. Here it is. So this is the nth derivative. Now, if he asks you to find the 1000 derivative, you don't need to differentiate for 1000 times. No, just you need to put n here equals to 1000. Excellent. We will have a question like this at the end. Now, differentiate this function. To differentiate this function, you can look at it as what? A product of two functions. Notice here that a and b are constants. So they don't depend on t. They are real numbers like 2, 3, whatever. So to differentiate, you need to find the derivative, the first, the product rule, the first times the derivative of the second times the derivative of the first. And here, this is a constant, so its derivative is 0. The bt, what is the derivative of bt with respect to t? It is b, because this is a constant. By the product rule, by the way, if you want, you can apply the product rule. It will be the first one multiplied by the derivative of the second plus the derivative of the first times the second. So now the b times the second, it will be b times 1. And here, the derivative of this constant is 0. So here you will have b times 1 is b, plus 0 times t is 0. So you will have b at the end. But we have it from before. It is a multiple constant. You can get it out. So we have here b, and here we have square root of 3. And here we will have what? The square root of 2, the derivative of the square root of 2, it is what, ya shabab?
Half over square root of t.
The derivative of it is a half t to the power negative a half. But no need to do that. I told you, you need to add it to your table. Add it to your table of derivatives, and the derivative of the square root will be just 1 over 2. I don't prefer to use this. The derivative of t, of square root of t, it is directly 1 over 2 square root of t. Just use it this way, ya shabab. It is the same, but it will be much easier. You don't need to simplify. Look what he will do. He will rewrite it like this again. So you will save one step at least. Now you need a shabab to simplify. So this is square root of 2 b square root of t, and this will be in the denominator. Now you need to write it as a single fraction if you want. It will be better. So write them over the same denominator or the same LCD. Believe it or not, there is an easier way to solve this. So don't always think about the product rule. Sometimes you don't need to use the product rule. The another way, it depends on this. You can see clearly that this is t to the power a half multiplied by a plus bt. So this is just what? A to the power t to the power a half plus bt to the power 3 over 2. Am I right?
Yes.
So you, as another solution, you can write it as a power function like this. Now the derivatives will be easy. If you want to find the derivative, it is sum. So you will just apply the sum rule. So what it will be the derivative? The derivative will be a half times a t to the power a half minus 1, which is negative a half, plus 3 over 2b t to the power a half, because 3 over 2 minus 1 is a half. Now you can simplify it. Now it is a matter of writing it in this way. It is a matter of simplifying. If you want, you can continue. Let's have another example, and this is in fact not direct one. This is the type of questions that you may have in the quizzes or in the exams. You have f of x equals to this, a square root of x times another function. We don't know what is this function, but we know that the value of it is 4 at 2, and its derivative at 4, it is 3. Now what you want to find the derivative of f at 4, f prime at 4. F prime at 4. What will be the derivative at 4, ya shabab? To find the value of the derivative at 4, it will be better if you can have the derivative in general. What is f prime of x in general? If you have it, just put x equals 4. If you have it, just go and put x equals to 4. Now, do we have f of x? If I have f of x, I can have f prime of x. I have it, here it is. So just take the derivative of this function. And this function is a product of two functions. So I'm gonna apply the product rule. So the derivative of this product will be the first times the derivative of the second plus the second times the derivative of the first. Again, it will be easier if you know directly what is the derivative of the square root. So this is the square root of x, g prime This is using the Leibniz notation. This is using the Newton notation. And this will be, of course, again, I don't prefer this way. I want you to write it this way. It will be easier directly. Here it is log. So you will save here this step if you did it. Now, this is f prime at x. What do you want? You want f prime at 4. So just put x equals to what?
4.
That's it. So instead of x, put 4. So it will be square root of 4, g prime at 4, and so on. So now what is g prime at 4? We have it. Here it is.
3.
And g at 4, it is here. So it is done. It is a matter of simplifying. Now let's come to the quotient rule. For the quotient rule, again, I told you, it will be in words. Let's read it in words. It says what? It says that the derivative of a quotient, the derivative of the quotient of two functions, is the denominator times the derivative of the numerator. Look, the denominator multiplied by the derivative of the numerator minus, be careful about this, it is minus, not plus, minus the numerator minus, where is minus? Here it is, minus the numerator times the derivative of the denominator, all divided by the square of the denominator. Square the denominator. So if you have f over g, all you want to find the derivative, what you need to do, just write a big fraction bar here, the square the denominator. Here, both the denominator times the derivative of the numerator minus the numerator multiplied by the derivative of the denominator. It's like this. Now add it to your table of derivatives that I told you about. The proof is similar to what we did, ya shabab, in the case of a product. If you are interested, also it is available in your book, but it is not clear. My proof here is easier. I advise you to prove it using the derivative, the f of t minus f of t minus f of x over g of x, and add here a term that is going to help you. And if you are interested, I can prove it for you later. Anyway, the derivative of the quotient rule, what we call it the quotient rule. Now let's apply it for this function. If you want to apply it for this function, you can see clearly that you have a quotient here of two polynomials. So it is easy, just this is g, this is f, and this is g. Apply now the quotient rule. So what it will be? You, first of all, you will write a long fraction bar. You will square the denominator, step number 1. Now you will multiply the denominator by the derivative of the numerator. Be careful, don't mix up between them, because here, if you make this at the beginning and this one here, it will be wrong, because you know that the subtraction is not commutative. You can do that in the case of addition, in the case of the product rule, but not here. So it is the denominator multiplied by the derivative of the numerator minus, don't forget this minus, open brackets to avoid any mistakes, and this is the numerator multiplied by the derivative of the denominator. And you know how to differentiate these functions. It will be what? What is the derivative of x squared plus x? It is 2x plus 1. The derivative of this x cubed, it is 3x squared plus 0. The derivative of 6 is 0. Now you need to expand. Don't try to simplify here, shabab. You can take something as a common factor, but there is no common factor between this term and this term. There is no. So what you have to do, some of you, they cancel this with this. I don't know why. This is an algebraic mistake. It is not. What you should always do, if there is no common factor here, take it out if there is a common factor. If there is no, expand. Multiply this and multiply this. Combine the like terms. Make sure about the negative sign. Don't forget it. And at the end, you will have something that is like that. You can stop here. If you can factor more, if you can simplify more, do. But here, I think you cannot. You will stop here. Example number 5, find the equation of the tangent line to this curve at this point. So also this is the not direct question. What is the trick here? What is the tangent line equation? Do you remember what is the tangent line equation, Shabab? It will be y minus f of a at a point, at x equals a, equals to the derivative of a x minus a. This is just, Shabab, the equation of the usual slope that you had before. It is the same. Now this was x1, we using x1. So this is what we are going to do now. Instead of the slope at that point, we will use the derivative and we will use that point. Now the point is given for me. Here it is. So what is A? A is 1.
1.
So this is A. So we have here x minus 1. And here f of A, it is given also for me. This is f of A. It is a half of E. What is remaining is the derivative at 1, f at 1. What is f prime at 1? To find the derivative at 1, you should ask yourself, what is f of x first? F of x, it is e to the power x. Here it is. It is e to the power x over 1 plus x squared. Now, to find the derivative, you can see clearly that this is a quotient of two functions. It is a quotient of two functions. So if you want to find the derivative, what you need to do, you need to apply the quotient rule. So this is the first step that you need to do. After that, you will come back here and put the value of it as 1, and you will find the equation of the tangent line. So now, according to the quotient rule, it is the square of the denominator. Here, the denominator multiplied by the derivative of the numerator minus the numerator multiplied by the derivative of the denominator. You can skip this step. You can go directly to here, but you have to be careful. There is no need to write this step, but it is there. You have to realize that it is there. Look, this is the denominator squared. The denominator multiplied by the derivative of the numerator minus the numerator multiplied by the derivative of the denominator. Now take e to the power x as a common factor, or you can simplify. It is a common factor. Take it as a common factor. Here it is. Now, can you simplify this or factor it? Yes. It is 1 minus x all squared. Can you cancel something with something? No, you cannot cancel here anything. Now, this is ya shabab, this is f of x prime. This is the derivative of x. What you want now, you want the derivative at 1. So this is dy dx. I want now dy dx at x equals what? At x equals 1. So this is f prime at 1, shabab. This is, of course, the Newton notation. This is the Leibniz notation. So this is what we have according to the tangent line at this point. The slope of the tangent line at this point will be the derivative at 1, which is what? What is it, ya shabab? It will be 1 minus 1. 1 minus 1, it will be 0. 0 over what? 0 over 2. Over 1. Or over 2. It is over 2, yes. It is over 2 squared. It will be over 4. So it will be 0 over 4, which will be 0. What does that mean?
It's a horizontal line.
It means that the tangent line is horizontal. So the derivative here will be 0. So this term will disappear. And you will have only y minus a half of e. So which will be equals to y equals a half of e. So this means that the tangent here is horizontal because the derivative at that number is 0. Any question, Shabab? Is that clear? Let's go to the next. Yes.
Clear, doctor.
Yes. Okay. Now, if I'm asking you, Shabab, to find the derivative of this function, what you will do? If I ask you to find the derivative of this function, 3x squared plus 2 square root of x over x. Many of you, they will think about what? The quotient rule, okay? But you can use the quotient rule. It's okay. But don't use the quotient rule every time you see a quotient, because sometimes it is easier to write the quotient first to put in the form that is simpler. In this case, it is easier to write it this way: 3x squared over x. I think I have it here. It is there. So first of all, separate, and this is what we do when you have, Shabab, when you have a plus b over c. This is a over c plus b over c. You can do that. This is true, but one of the mistakes that the students do, that when you have a over b plus c, this is not a over b. You should know this clearly from MATH101. So this is not true. Be careful. So if you have it this way, you can now simplify it. So it will be 3x squared over x, which will be 3x. Look, this is the function, not the derivative. Now here you will simplify it. It will be x to the power negative half. Now you can now find the derivative easily. What will be the derivative now, Shabab? It will be the derivative of this is a 3. The derivative of 2 will gone with a half. It will have negative x to the power negative 3 over 2. You can simplify it, writing it as a 3 minus 1 over square root of x cubed. Because x is positive here. Why x is positive? Because it is under the square root. You can write this as x square root of x. And
can't
of
take-
course, we can simplify it more. It will be 3x square root of x minus 1 over x square root of x. Yes.
We can't take x as a common factor at first. It will give the same answer.
Yes, of course. This is the same answer. Separating here is much easier. Now, if it was like this, Shabab, if this function, it was like this, x over 3x squared plus 2 square root of x, in this case, you have no choice. You have to apply the quotient rule. There is no another option. Do you agree with me? Here you cannot separate. You cannot write it as a power function. You have to use here the quotient rule. Any question, Shabab? Now let's, yes. Now let's summarize, Shabab. Until now, we need to update our table of differentiation formulas. Okay, so 3.1 and 3.2 until now, the derivative of the constant is 0. The constant of the power function, the derivative of the the derivative of the power function, the derivative of the natural exponential function. When you have a function multiplied by constant, the derivative will be the constant. You can apply the product rule here, by the way. If you apply the product rule, it will be clear. The sum and the difference, it is easy for them, just distribute. Now you have to be careful about the product rule and the quotient rule. You can add, of course, your own derivatives to this table. And these are the suggested exercises. We are done. This is 3.2. We are done with this section. It is just about two main ideas, the product rule and the quotient rule. I want you, Shabab, to solve this, please. I will give you 3 minutes to solve this. Please try to solve it. During that, Shabab, I want you all to raise your hand. Please raise your hand. I will take the attendance by raising hands. If you didn't raise your hand, you are absent. Where are the other guys? Raise your hand. Ali Abdurrahman, علي الداود, علي الشمراني, علي رافي, حسام الأحمدي, حسين مسعود, إبراهيم بابطين, محمد الخطيب. You didn't raise your hands. Go to participants, click on participants, and you will raise your hand. Where are the other people? Yes, I will make you absent if you didn't raise your hand. I don't want a ghost on my lecture. I want a real person to attend the class. Ali Shamrani. Raise your hand, ya Ali. Abdurrahman Ali, Abdurrahman, Ibrahim Babtain, Muhammad al-Khatib. Muhammad al-Khatib, can you hear me? Raise your hand.
I can hear you, but I don't know.
Can you see participants, ya Muhammad? Click on participants. You will find there, raise your hand or say yes or no or whatever.
Yes.
Abdullah Midraj, why you are not raising your hand? Abdurrahman Ali.
I'm Abdullah Midraj, doctor. I don't know how to raise my hand.
This is not yet the first time that we talk about this, ya Shabab. Please grow up. Go to participants. عندك participants at the bottom of the screen or at the top. Participants. Click on participants. You will find there a hand. Click on it. You will find also yes, no, and so on. Abdurrahman Ali, can you hear me, Abdurrahman? So Abdurrahman is absent and Ibrahim Babtain is absent. I will take a picture of this and hello. You will be absent. I will not take the attendance from the report today. I will take it from here.
Yes,
Ibrahim Babtain.
Yes.
Why you didn't raise your hand?
I didn't hear you. I'm sorry.
Raise your hand, ya Ibrahim. Can you hear me now? Abdurrahman Ali, where is Abdurrahman Ali? Abdurrahman Ali is absent. Done. Okay, شباب. Let me launch polling, by the way, it is okay, to see who has an answer and how they obtain it. You can choose the right answer, شباب. Next week, inshallah, by the way, I will announce in the next class, inshallah. Next week, شباب, we will have 2 quizzes at least. We need to practice, شباب, more before the midterm. So we may have two quizzes or 3 before the midterm. Is that okay for you?
Yes, Dr. Rabi, والله نبي نعوض.
Yes, doctor. It's better to have.
ان شاء الله اذا ودكم تعودوا يا شباب شدوا حيلكم على الميد تيرم. 25 درجه راح تفرق كثير جدا معاكم، خصوصا ان السكاشن هذول هم اسهل سكاشن في الكورس.
دكتور
متى بيعطونا درجات الاونلاين اسسمنت الاول؟
as soon as possible، يعني ما راح يخبوها عنكم، اذا هي جاهزه راح يعطوكم هي. Don't worry، خلاص it is from the past now. Whatever it is from the past. يعني بخيرها بشرها خلاص راحت يعني. Whatever you got there it means nothing, because if you get bad grade you can make up. If you got a good grade, this is good, but there is no guarantee that you will get the same grade in the midterm or in the future exams. So it is you still playing يعني. إذا جاك جول ولا سجلت جول في الشوط الأول ما هذا لسه ما صفر الحكم. في الشوط الثاني كل شيء ممكن يصير. Okay, let me يا شباب end the polling and share the results with you. Look, you didn't agree. I wish that one time you will agree about. I think they have changed the time of the MATH101 mid to 20 of October. Yes, I think so, but they didn't inform us officially. Always يا شباب don't listen to what people are saying. Just wait, check your email. If you get something in your email, this is true. And this will save your time. You waste your time looking for what they say, what they said. Oh, don't waste your time doing stuff like that. If there is something official, if there is something official, you will have it.
دكتور هو مكتوب في الايميل يوم يرسلون لنا تختار المدينه اللي راح تختبر فيها انه الماث 101 102 يوم 20
Okay. خلاص, that's it. But what I showed you, شباب, it is what written 18th according to the previous syllabus. It's okay. Now, who find يا شباب, who find the solution in the right way? Do you know what is the right answer? The right answer is A. The right answer is A. Why and how? Who choose A, شباب? Anyone choose A and he can share with us his answer?
You find the first derivative and the second, and you can notice the pattern.
Yes, يا نواف. Excellent. أحسنت يا نواف. So the idea here, شباب, is to find the first derivative and then the second, the third, until you have the nth. So to solve this, you need to have a formula for the nth derivative of this function. It will be a function of x, and then put n equals to 101, and put x equals to 6. So this is our plan now. طبعا يا شباب, after 3.4, when we study 3.4, you can use the product rule here. You know that the product rule is easier than the quotient rule. So you can write this function as e to the power negative x. But if you take the derivative now, you have, what will be the derivative? The first one multiplied by the derivative of the second. What will be the derivative of the second? It will be negative e to the power negative x. Why? We will see that in 3.4. So I prefer now to use the quotient rule. So let's use the quotient rule that we have in this section. So now, according to this, what will be the first derivative? The first derivative, ya shabab, will be what? The square of the denominator, which is, by the way, what is the square of e to the power x? It is e to the power 2x. You know that. Now, the denominator multiplied by the derivative of the numerator plus the numerator multiplied by the derivative of the denominator. So this is what we have. Let's take e to the power x as a common factor. It will be 1 plus x, what is left there, over e to the power 2x. Now you can cancel this with this, and you will have at the end 1 plus x over e to the power x. So I'm going to write it here يا شباب to save the space.
Is it minus?
The first derivative يا شباب, it is minus. Yes, thank you. Thank you very much. It is minus from the rule. Oh, it is a mistake that I warning you about it and I did it. So this will be when you take e as a common factor, it will be cancelled with what you have in the denominator. So it will be 1 minus x over e to the power x. So this is the first derivative. Now let's go to the second derivative. The second derivative will be what? The square of the denominator again. Here you will do the denominator multiplied by the derivative of this. What is the derivative of 1 minus x? It is negative 1 because 1 is 0, negative x is 1, negative 1. Minus, don't say plus, minus the numerator multiplied by the derivative of the denominator, which is itself. This denominator, of course. This denominator, I mean. Not this one. Not after the square. Be careful. So after the simplifying, you will take this as a common factor again. Again, you will cancel it with what you have in the denominator. Now you have here negative 1. Negative 1, it will be negative 2. And here it will be x. So it will be x minus 2. Is that right? So you can notice that, of course, here it is like x minus 1, but negative. Do you agree with me? 1 minus x, you can write it this way. It is x minus 1, but negative. This will be x minus 2. Now, if you did find the third derivative, let's find the third derivative quickly, ya shabab. And we can, after that, guess the pattern. So now the third derivative will be, again, the square of the denominator here. The denominator multiplied by 1, which is the derivative of the denominator, minus x minus 2 times the derivative of the denominator itself. Take this as a common factor. Cancel it with what you have in the denominator. Now you will have what? 1 minus x minus 2, it will be plus. So it will be 3 minus x, which can be written as negative x minus 3. Check that again. So can you now conclude what is the nth derivative of x equals to what? It will be equals to, here in the denominator, we will have e to the power x. In a here or here or here, whatever. Look, this is the second. This is the third. This is the first. So in the denominator, we have e to the power x. Here we have what? We have x minus 1, x minus 2, x minus 3. So we will have x minus n. Now, what about this? What is the story of this negative? We have here negative, because here it was here 1 minus x. Here it is x minus 2. Here it is 3 minus x. So it is alternating, one time positive, one times negative. Notice what? That when the order of the derivative is 1, it is negative. When it is 2, it is positive. When it is 3, it is negative. So this means it is about even and odd. So do you remember what is negative 1 to the power n? Negative 1 to the power n, shabab, it is 1 if n is even. And it is negative 1 if n is odd. Do you remember that? So this is what we are going to write here. It will be negative 1 to the power n. This will give me negative if n is odd, and will give me positive 1 if n is even. Now this is the nth derivative at x. What I want now, I want the nth derivative, I want the 101 derivative at 6. So I will put n equals to 101, and here I will put x equals to 6. 6 minus 101 over e to the power 6. Simplify. Negative 1 to the power 101 will be what?
Negative 1.
It will be positive 1 or negative 1.
Negative 1.
Negative 1.
Negative. It will be negative because it is odd. It will be negative 6 minus 101. It will be what? 95 with negative over e to the power 6. So this negative times negative will be positive 95. This will be e to the power negative 6 because it was in the denominator. I can write in the denominator, and this is exactly what we have here. So look, ya shabab, this question they make look tricky, but just you have to be careful and do it step by step at the beginning, and you should know how to solve it at the beginning. This is the most important part. How to solve the what is the plan, the solution plan. Again, shabab, if you want to practice, you should go and practice without looking at the solution. Try and try. Any idea here how to find what you want to find? You want to find tangent line of this curve. So you will find the derivative and then you will evaluate it at 4. Just like that. And be smart. You can use the quotient rule, but you can use what? You can write it like x to the power a half minus x minus 1 negative half minus 2. Now take the derivative. It will be negative half of x, negative 3 over 2 minus 0. So here it is. It will be negative 1 over 2x square root of x. Now put x equals to 4, what you will have y prime at 4 and so on. So try to practice and practice, especially Shabab, the strange ideas, when you have ideas that they are different. Why this question is repeated? Oh, I repeated now to practice. Similar questions like this you may have, Shabab. So please practice as much as possible. This is the end of the class. This is all what we have for today. See you inshallah next